In this video, we'll demonstrate some short little programs that we can use to demonstrate variables and how they're used in code. And so here we have a program, it's called Piano Keys, and these can be found in your textbook if you have a copy of my old book that uses, they're actually in chapter 2, but it's 1.2 from our unit in the AP Classroom. And here what you can see is we have our regular top part of the program. We'll jump down to our main method. And here in our main method, we have declared our variable, and the variable will always declare a variable up at the top. And that way, later on in the program, there's no confusion where the variables are, where they're declared, always up at the top of our code. And then I can use it. Once I've declared it to be an integer, that means there are now 32 bits of memory set aside that will store information with a variable name. What we're doing, instead of having to know all those different memory locations and hexadecimal numbers and stuff, we can just use the word keys. And keys stores the value or references the value 88. Now later on we're going to learn about class variables. And class variables and objects, those are totally different. All right, but primitive data, we just reference the value that is stored there. So when I say keys is currently 88. Now that value can change, as we'll see in another program we have. So when you print out a piano has keys and then the word keys, it will print out, and I'll save it and run it. It will say it has 88 keys. Kind of obvious and hopefully pretty simple. All right, let's take a look at the next one. This is a program called Geometry, and in this one we're demonstrating how you can change the value that is stored. So just like before, I declare and initialize my variable before I use it. And so I'm declaring an integer variable of sides, and I'm putting the value 7 in there. So sides represents the number 7, the value that is stored there. So when it says a heptagon has sides, it will say 7 sides. Okay, then we can change the value, and the way we change the value looks just like the way we initialized it, but we don't say int again. If I try to declare another integer value and I say int sides, it's going to give me an error. It says there's a duplicate local variable called sides. You can't have two variables with the same name. So what I'll do is I'll take that out. Now I'm changing the value that is stored. By the way, notice when I click on sides, it highlights all the uses of sides in my program, so I can kind of follow it along. It's pretty convenient in Eclipse. But I've now changed it to 10. So when it says a decagon has sides represents the value that is stored there, so it replaces sides with the value 10. And of course then with dodecagon, all right, that change the value to 12, so sides represents the value of 12 when it prints. And I'll save it and I'll run my program, and there you can see how each one printed out just as we expected. Okay, and then finally the last one, this one demonstrates the constant. All right, so if I look at the temp converter, here is the temp converter program, and you can see here we have used the final keyword. When we use the final keyword in Java, what we're telling the computer is that now this variable base has to remain 32. If I ever try to change it later on in the program, it will give me an error. So when you declare and initialize, you have to declare and initialize all constants at the very beginning. So final int base equals 32. Right? Base now always represents the value. So it's not like the previous program where I was able to change base. I can't do it. And because of that, that's why by convention we capitalize all constants. All right, and then we have another one called conversion factor, and it equals a number because 9.0 divided by 5.0 is an equation. So that answer, that equation gets put in here, so the 1.9 or approximately gets stored in conversion factor. All right, then I have some regular variables called Celsius temp 24, and I have a double Fahrenheit temp. Now notice that Fahrenheit temp is not being initialized. Okay, all our other ones are initialized. The constants have to be initialized. This variable doesn't have to, but before I can use Fahrenheit temp, I will have to find a value for Fahrenheit temp, and then using the Celsius temp and the conversion factor in the base. All right, now when I say I want to print out Fahrenheit temp, it will work because I've declared it and initialized it. So that's not uncommon either, to declare it on one line and initialize it on another, but you have to do both before you can use that variable, or you'd get an error. Okay, so those are just 3 little samples. In the next video, we'll give you a chance to practice some of this on your own.